Question 10, find the term of the find the next term of the sequence. So our sequence goes oh, got it. So our sequence is what? 22, 17, 12, 7, 2. 22, let's make that a little bit thicker. 22, 17, 12, yeah, 7 and 2. I'm actually just a little bit thirsty. I think I might be slightly allergic to something in this chocolate. Yeah, it's fine. Look, I don't generally have a nut allergy. Just if you see me like not breathing, just like call Katoshka or something, okay? I'm joking. That's a joke. um, we've got 22, 17, 12, 7, 2. So what type of pattern is that? Okay, so we're decreasing by 5. So from 22 to 17, we've got 5. We've got minus 5. Okay, and this is question 10a. So what is our next one going to be? Okay, so yeah, -3 is correct. Now, let's do a bit of an exploration here. What type of pattern is this? What type of numbers, what types of number patterns do we get? Another way to say number patterns is sequences, hey? I don't know which one that is. Okay, these are the ones I can think of. I've got the linear sequence. And these have a constant difference. Like every time it's exactly the same. Okay. Then we've got a quadratic. That also has another name which I had in my head and then I lost it. But we've got a quadratic sequence, and that basically it has a constant second difference. Let me explain what that means. Basically, that means that while the difference between those aren't the same, if you write these little numbers down, the difference between those will be the same. So like below this, that will be the same. Another one I can think of is there we go. Let's just delete this quickly. Another one I can think of right now is a geometric sequence. And a geometric sequence basically has a constant ratio. So the ratio between the first one and the second one and the second one and the third one are the same. Okay, so let's create one quickly. So if I've got 5 and 10, okay, to get from 5 to 10, the ratio from 5 to 10 is actually, I think I want to do a separate lesson on this because there are 2 ways that this can be explored. Okay, so I want to actually figure out a good exploration for this. Then there is a fun one. I really, really love this one, and you are not required to know it. Okay. And I can't actually even remember what it's called or the notation of it. So, but basically, there is no use for it. Like, no use. Because what happens is we take 2 to the power of 2. Then we take so let's work that out. Our first one is going to be 2. Our next one is going to be 2 to the power of 2, which is 4. Then we've got 16. And take that and we put that to the power of 2. Then we've got 256. I'm going to square that one. We've got 65,536. We're going to square that one again. And 1, 2, 3, 4, 5, 6 numbers in, we are 4 billion 294 967 and 296. So 4,294 million 967,296. So this is quite a cool one, hey? There is a notation for it. I think it's 1, 2, 3. I can't remember even what the notation is. I can look it up for you. But I really, really enjoyed this one. I actually learned about it maybe a year ago. Because it's not really something that people do. Because it's incredibly nerdy to do. So, yeah.